conversion first. Now, I'm going to highly suggest you memorize what I'm about to put on the board, and then what I would say is you'll come in here, you'll pick up an answer sheet, I'll get you line up against the windows, and while you're doing that, while you're filling in your name and your section and all that, write this down on the back of the test, okay? So remember, we start out like 10 to the 9th, 10 to the 6th, 10 to the 3rd, 10 to the 0, 10 to the -1, 10 to the -2, 10 to the -3, 10 to the -6, and 10 to the -9. Okay? I'll let y'all figure out what the abbreviations for all that is, but as far as you need to know for the conversion, write it horizontally like this so you know right and left, and then all you have to do, like let's take one of the measurements off your review. Let's do, from right here, we got 368 millimeters. And we are going over to, actually that's nanometers, so we're going over here to micrometers. All right? Remember, if we're staying on one side of the 10 to the 0 or the other, you take the larger number, you subtract the smaller number from it. So this would be the absolute value of 6, and you subtract 3 from it. So this is 3 stages. Okay? And we know we're moving to the right, so we move the decimal point to the right. So we take 368. And that is 0.0, and we just move it over 1, 2, 3, fill in with zeros, put the decimal point over here, and always change your abbreviation for it. If you do not have this little abbreviation for whatever you're converting to, the answer is wrong. Okay? So make sure to put in your little prefix and suffix. Yes?
So that number is 10 to the -3.
We went from 10 to the -3, which is millimeters, and we went to 10 to the -6, which is micrometers. The next one would be 10 to the -9th is nanometers. Okay? Now, if we're moving across a 0, like we're going from 368 here to, this would be kilometers, 10 to the 3rd. Remember, we take the two numbers and we take the absolute value of them and add them together. So we go 6 plus 3, which would make it 9, and we are moving the decimal point, we're going to the left. So you take this and you go 1, 2, 3, 4, 5, 6, 7, 8, 9. Put your decimal point in, fill in with zeros. Change out the prefix to kilometers. And you're good to go. Okay? Most of y'all should have this. I believe y'all put it into your interactive notebook. Yes?
Should you have only moved 6?
No, remember, we take 6 plus 3.
I thought the -3 though was for the millimeters, and you moved...
Oh, wait a minute. 3 plus 3. Yeah, you're right. My screw up. Okay, so that's 6 spots. There we go. You learn to erase stuff that makes me confused. So that would have been a 6. Okay. Other than that, there are several conversion problems in both your lab, in the review, and in the post-lab questions that they were asking you to do. So, take that, practice it over the weekend. Now we're going to move to this front table right here and start talking about measurements. Currently, we are still on lab number 1. Okay, measurements here are always done in the metric system. Temperature is always done in Celsius. They are going to ask you for the boiling point and the freezing point of water in both Celsius and Fahrenheit, so be sure to memorize that. Other than that, remember we measure these to the closest accuracy of the instrument. So on the thermometer here, we can do it into like 1 degree. Okay, try not to do any guesstimates. Like for this one, it's reading 22 degrees and a little bit more. So don't say 22.3. Just do it to the closest degree. On the triple beam balance here, I will make this warning today, and I'll make it again when we get to the test. we are going to set this thing. All you have to do is read it. Please, no one touch this thing, because I had a near riot a couple semesters ago because someone thought, that just is a little bit off, so I'll change it and make it right. And it made 3/4 of the class miss the question, and I thought they were going to lynch the person, so it was not good. So whatever the triple beam balance is, just leave it and read it. That's all you have to do. Okay, triple beam balance is always measured in grams, and this can measure down to 1/10 of a gram. Okay, so that's as far down as you have to go. With the measurement of volume here with the graduated cylinder, remember, we leave the graduated cylinder on the table to read it, and we get down to the level of the water and put the water at eye level. Okay? We're also looking at, on the water here, there's a distinct curve called a meniscus, and we are looking at the bottom edge of that curve from where we do the readings. Like this one right here is set, well, like I said, you're not supposed to read it from the air. It's set at 30 milliliters right now. All right. Length. There's two ways that you're going to be asked to do measurements here. You may be given the bones here to make a measurement. If you do that, remember, there were 2 ways you could do this. You can either put them down like this and do them to that side. Now here's the question. Is that the correct side of the meter stick to be measuring from?
No.
No. Make sure you are on that side. Remember, you can start anywhere that you want to. And do y'all remember my way of, I told y'all to measure this? Flip up the, like that. Flip these up like that. Now, for the bones here, I might give y'all a little bit of leeway, like maybe 0.4 centimeters on here, either way. But if it's a full centimeter off, the answer is going to be wrong. Okay? Yes?
For the lab practical, is it already going to be set up, or we have to measure it ourselves?
It will be set up like this, and then you have to make your own measurement. The other way that we can do this is, if y'all remember, we had these smaller rulers here. I will tell y'all, this is almost a guaranteed question on there. I don't know why, but it always makes it onto the lab practical. They will give you a line, and then they will ask you to measure it with the smaller ruler here. And then what they usually do is, after you measure it, and you measure it down to the nearest 1/10 of a centimeter, they then ask you to convert the measurement into one of the other lengths. Okay? But up to here, if you want to stop your recordings right there, that's all of lab number 1. Yes?
Is there, for length, do we measure to millimeter? No. Yeah.
Well, remember, 1/10 of a centimeter is a millimeter. So. Okay, so that takes care of all of the lab number 1. We have to go to this table right here to get to lab number 2. Okay. Alright, first things first, on most of these, you will need to know what color represents what atom. Okay? So black is carbon, yellow is hydrogen, red is oxygen, and blue is nitrogen. Now, for everything on this table, except for water, all the rest of this are organic molecules. Okay? Because they have carbon in them. I think I told you these rules the day you did this, but if you didn't get them, write this down right quick. Easiest way to figure out what these are, rule number 1, count the number of carbons. If it's 1 carbon, it's methane. If it's 2 carbons, it's ethane or ethyl alcohol. 5 carbons, and it's either ribose or deoxyribose. 6 carbons, it's usually glucose. And then if there's any nitrogens associated with it, that would be one of the amino acids. Okay? Second rule, count the number of oxygens. The number of oxygens will allow you to determine the difference between deoxyribose and ribose. Ribose has 5. Deoxyribose has 4. Third one, notice the positioning of the OH